First thing new today is you need to know the difference between a solvent and a solute. Okay? So you need to know the difference between a solvent and a solute. Difference between a solvent and a solute. Do we know what the difference is between a solute and a solvent? Anyone know? Okay? When you put two things together, say we put Kool-Aid and water together, right? What's the solvent?
The water.
The water, right? So it does the dissolving. The solvent does the dissolving. The solute gets dissolved. Okay? So if we're mixing sugar and water, the water would be the solvent. The sugar would be the solute, right? Everyone got that? So what's the solvent? What does it do? It does the dissolving. What's the solute? It gets dissolved. Good. Okay? So if we mix, say we mix Kool-Aid and water. What's the Kool-Aid? The solute, because the Kool-Aid gets dissolved, right? Okay? What happens if you put too much solute in it? More than can be dissolved. What happens to the extra solute? It goes to the bottom, right? Can it all get dissolved? Right? At some point, the water is going to say, okay, well, I've dissolved as much as I can, right? Just like if you put too much sugar in your tea, what happens to a lot of it?
The sugar
Goes to the bottom, right? So it can only hold so much. Okay? So that's solvent and solute. The solvent does the dissolving. The solute gets dissolved. Bridget, what's the solvent? What's the solvent? The dissolving. 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 Okay? And the solute? Okay, you say it with the group and I won't have to pick on you. You're like Wendy was yesterday. Now she's participating. Okay? Now, the next thing. Water is the universal solvent. What's the universal solvent?
Water.
Water. So do you think it's ever going to be the solute? No, water will never be the solute. It is always the solvent. Water is always the what?
The solvent.
The solvent. What's water?
Solvent.
Always the solvent. Okay? Water is always the solvent. Why? Your next question would be why? Why is water always the solvent? Why does water do anything it does?
Because it's polar.
Good. Because water is polar. Okay? Why does water do anything it does? Because it's what? Polar. What is water? Polar. Okay? So if on the test it says, why does water freeze on top instead of freeze on bottom? Because it's polar. Okay? Why does water flip over desks? Because it's polar. I don't care what it says on the test. Water is the way it is because it is polar. Why is water the way it is? It's polar. What is water? Polar. Okay? They might say polarized, polarization, but water is polar. Okay? As long as you see the word polar, if it's talking about water, the answer you're going to choose is going to be the one with polar. Okay? Now, what does it mean to be polar? Okay? What do we know of that's polar? A magnet, right? A magnet has a North pole and a south pole, right? So it has a positive and a negative end, right? Everyone agree? So what do you think a water molecule looks like?
Positive and negative.
It looks like a magnet, right? It has a positive and a negative. So what is water? How do we describe it? H2O, right? H2O equals water, which means it has how many hydrogens?
2.
Good. 2 hydrogens and how many oxygens? 1 oxygen. So H2O is the chemical formula for water, which means it has 2 hydrogens and 1 oxygen. And what it looks like is like a Mickey Mouse. Okay, a big face and 2 ears. Okay, so what do you think these are, the 2? Hydrogens. So they're H plus. Hydrogens are positive. And we'll go more into why they are positive later. Okay? H plus, and then oxygen. What do you think the charge of oxygen is? Negative. Okay? So do you see how it looks like a magnet? It has a positive end and a negative end. Right? Does everybody see that? Yes? No? Okay? So then, if you add another water molecule to it, right? Because it's water, is this just one big water molecule in here? In my fish tank? No, water in a fish tank is not just one big molecule. It's what? Billions of them, right? So how do they form? Well, one water molecule sticks to another one. So what do you think? Do you think the hydrogen end is going to be right here? Okay? And then you have your Mickey Mouse face again. Okay? So you've got the oxygen, the negative, and the hydrogen, the positive. Just like a magnet. The positive end sticks to the negative end, right? Positive sticks to negative. Okay? So that's how they're going to work. Hydrogen is going to stick to your oxygen, and then they'll keep forming and keep forming and keep forming until you have this big chain of them, and then you get what we see as water. Right? So do we understand what water is? Polar. Okay? Now, how the other way polarization works is if you do have water and you throw some Kool-Aid or some sugar in there, a magnet, let's say we have a group of paper clips all stuck together. What would a magnet do to those paper clips? If this is 2 magnets, or this is 2 paper clips, right? My 2 pens are 2 paper clips. And I have a magnet over here. What's it going to do to this green paper clip? It's going to bring it towards it, right? And it may bring the blue with it, but probably it's just going to bring the green. Because what if I have 2 of them and I have a magnet here and a magnet over here? One's going to go to this magnet, right? And the other one's go to this. So what did it do? It pulled my paper clips apart. Okay? So that's how a water molecule works. It'll take your Kool-Aid that's put together in molecules, and one water molecule is going to take this one, and one water molecule is going to take this one. And now your Kool-Aid is spread out all throughout your water. Does that make sense? Okay? And so then, once the water molecules have taken as much Kool-Aid molecules as they can, what happens to the rest of the Kool-Aid that you pour in there? It sinks to the bottom. Okay? So the Kool-Aid is called the what? The solute. The Kool-Aid is the solute. The water is always the universal solvent. Okay? So if you put too much solute into water, the solvent dissolves as much as it can, and then what happens to the extra solute? It goes to the bottom, right? Because it can't dissolve anymore. Does that make sense? No? Does anybody have questions on what we just did? Everyone's good? Wendy, you confused? Not confused? Okay. You're confused. You good? Alright. Next word. An enzyme. What's an enzyme? Okay, someone tell me what an enzyme is. What does it do? Oh no. Ah, speeds up reactions. Okay? Speeds up reactions. What does an enzyme do? Okay, what is it that speeds up reactions? What speeds up reactions? Enzymes. Okay, what speeds up reactions? Enzymes. Okay, say it over and over and over again so you don't forget it. Okay, enzymes speed up reactions. Now, an example of maybe an enzyme that you can think of is metabolism. Anyone ever heard of metabolism? Okay? For example, an example of metabolism is how fast you digest food, right? So I have me and my brother. Me and my brother have the same mom, we have the same dad, and I can eat a lot more than my brother without gaining weight. So I have a higher or a lower metabolism than my brother? A higher, right? You've seen those people that they're skinny as a rail and they eat all they want, right? And then you see those some people and they eat like birds and they still gain weight, right? And you can't help that because it's your what? Metabolism. Okay? So if someone has a high metabolism, they probably have more enzymes that are going to digest the food. If they have a low metabolism, they have a low amount of enzymes. So if you have more enzymes, you can speed up the reaction. So the more enzymes you have, the more you're going to be able to digest that food. Does that make sense? Yes? Okay? And that can happen in any reaction. Okay? If I add water and Kool-Aid together and I want them to dissolve, how can I get them to dissolve faster? By adding a enzyme. If I added an enzyme, they would dissolve faster. So an enzyme, what does it do? Speeds up the reaction. Okay? Now, by speed up, the scientific word for speed up is to catalyze. Equals speed up. Okay? So you can say an enzyme catalyzes the reaction. Okay? What does catalyze mean? Speed up. So an enzyme catalyzes reactions. And what does that mean? It speeds up reactions. So what an enzyme do? Catalyze reactions. What catalyzes reactions? Well, no. What catalyzes reactions? Enzymes. What catalyzes reactions? Enzymes. Everyone got this? Any questions so far? Going pretty fast. All right. The next two words aerobic and anaerobic. Okay? To remember these, I want you to say it this way. Aerobic. Say it that way. Aerobic. Aerobic. Okay? And I want you to stress the air. Okay? And on anaerobic, I want you to say anaerobic. Anaerobic. Say that? Anaerobic. So when we see anaerobic, we're going to think anaerobic. Okay? Anaerobic. Okay? So then, anaerobic has air. When I ask you guys, what do you breathe in? You always go air. Right? You say, oh, I breathe in air. And by air, you really mean what? Oxygen. So aerobic is with oxygen. Okay, so scientifically they might say in the presence of oxygen. Okay, so aerobic is with oxygen. Does that make sense? Easy way to remember it. Aerobic. When you think air, we know that you mean oxygen. Right? So then how did we say this one? When we see anaerobic, it's anaerobic. So what do you think anaerobic is? No air, no oxygen. Good. So no oxygen present. Okay? So if I have an aerobic reaction, that means it must have what in the reaction? Oxygen. Right? And if it's an anaerobic, there must be no what in the reaction? There must be no oxygen in the reaction. So if I have anaerobic or aerobic, let's say I have aerobic respiration, that's respiration with oxygen. Do we go through aerobic respiration? Yeah, right? Because we breathe oxygen. Would there be any reason for us to breathe oxygen if we were going to go through anaerobic?
No.
No. Do we ever go through anaerobic?
No.
Sometimes.
Sometimes, okay? Sometimes when we run out of oxygen, when you're running and you're working out and your heart's beating real fast, you can't get enough oxygen, it'll go ahead and do it without oxygen, okay? So anaerobic, right? So anaerobic is no oxygen. Aerobic is with oxygen. Everyone got that? What's aerobic?
With oxygen.
What's anaerobic? No oxygen, okay? So no oxygen is what? What's no oxygen? Anaerobic. And what's with oxygen? Aerobic. Good. Awesome. Okay. The next thing we're going to talk about, this will be the last new thing for today, the pH scale. The pH scale. In the pH scale, every single substance can either be a what or what? What are we dealing with the pH scale? Acids and bases. Acids and bases. And if you're in the middle, you're called what? Neutral. Good. And if you're neutral, what's your number? Huh? Not 0. 7. Okay? And the pH scale is 1 through 14. If you're a 7, you're neutral. And that means that you are pure H2O. If you're 7, you're neutral, and that's pure H2O. Do we drink pure H2O?
No.
No, because when you look at your water bottle, it says Smart Water enhanced with minerals, right? Smart Water enhanced with minerals, or Dasani with minerals, right? And really, it's just water with minerals, and it's all the same. But is it pure water?
No.
No. So does the water you drink have a pH of 7?
No.
No. Okay. Now, what numbers are bases?
8 through 14.
Okay, good. We'll call it. Go ahead and call it 7.1 through 14, but 8 through 14 is good. Okay. So then acids are what? 1 through what? 6.9, right? Because once you hit 7, you're what?
Pure.
You're pure water. You're neutral. Okay? You're pure water. You are neutral. Now, the other thing we need to know about them is acids are H plus ions. H plus. So the more H plus you have, the more acidic you are. Okay? Now, on bases, it's the more OH negative you are. So the more OH negative you have, the more basic you are. Does that make sense? Okay? So then we can make our number line. Okay? Now, the way to remember this is if you look at the OH, right? How many letters in an OH? 2 letters, right? OH. How many digits are in most of the numbers for the bases? 2. 10 has 1 and 0, 11 has 1, 1. So there's 2 digits in most of these numbers, excluding 8 and 9. So they're the bigger numbers, so there are the 2 letters. Okay? If it's H, how many letters are in this? 1. How many digits are in all the bases, or all the acids? How many numbers are on all the acids? 1. So they must be the H plus, which is what? What's H? Hydrogen. And it's a acid. And if you're a base, you're OH, which is 2 digits. Does that make sense? Okay? So now, your next question you'd ask is, what is a stronger base? A 13 or a 9? What's a stronger base?
13.
A 13, right? What's a stronger acid? A 1 or a 5? A 1. Okay? Now, so that means that the farther from 7 comma, the stronger the acid or base, okay? So the farther from 7, so what's stronger, a 12 or a 10?
12.
A 12 because it's farther from 7. What's stronger, a 2 or a 4?
2.
A 2 because it's farther from 7. So it's really, really acidic, and then as it gets closer to 7, it becomes more what? More neutral. And then as it's at 14, it's really basic, and as it becomes far closer to 7, it becomes more neutral. And then once it hits 7, it is neutral, or pure water. Okay? Now, what do you think has more OH ions? A 9 or a 13? Which one has more OH in it?
13.
The 13, right? Because if it's stronger, it's going to have more OH. Okay? Because then when you get to, on this side, if it's what has more H plus, a 1 or a 3? A 1, right? Because it's a stronger acid, so it's going to have more H plus. Okay? Now, what do you think 7 is? Do you think 7 has what? Do you think it has more H or more OH? Equal on both, right? So 7, neutral, has equal H plus and OH negative ions. Okay? So if you are 7, which is neutral, you have equal H plus and OH ions. Does that make sense? So we understand the pH scale. It can either be an acid, a base, or neutral. And what's neutral? Pure water. And typically your blood is actually neutral too. But we won't worry about that. Okay? Alright. So that's all the new stuff for today.